Continuing a theme, you're going to feel like you've done the first part of this lesson before, and the second part of the lesson you haven't seen before. And that's been the theme of Chapter 4 to this point, where the first half of a lesson you've definitely seen before, and then we take it a little bit further. So, there's a bunch of vocabulary here. I'm going to come back to it. I'm going to jump straight to the first example. Determine the relationship between the x and y values, write an equation. I'm doing that because you've done this before. So, how does x become y? How does 1 become negative 2, 2 become negative 1, 3 become 0, and 4 become 1? Because whatever rule we find has to work for every ordered pair we're given. And as you're looking at it, I want you to try two things first. Now, I don't care what order you try them in. I want you to try to figure it out using just multiplication or division, and I want you to try to figure it out using just addition or subtraction. If and only if you cannot do it with that, should you start thinking of more complex things like doubling the x value and then adding 1. So we go simple first, and we go with more complex if and only if we have to. So, 1 to negative 2. Well, I could do that by multiplying 1 by negative 2. But if I try to do that again with the next value, 2 times negative 2 is negative 4. And I'm not looking for negative 4, I'm looking for negative 1. So it's not multiplication. At least it's not multiplication by itself. We will try addition or subtraction. And since these values are obviously getting smaller from x to y, it'll be subtraction. So how do I get from 1 to negative 2? I subtract 3. Does that work as I go forward? 2 minus 3 is negative 1. 3 minus 3 is 0. And 4 minus 3 is 1. So our y values we're getting by taking our x values and subtracting 3. You've done this before. Determine the relationship between these values, write an equation. So this time it's an ordered pair. Who cares? The question is, how does 1 turn into 3? Let's say times 3. Does 2 turn into 6 by multiplication with 3? Yes. Does 3 turn into 9 by multiplying by 3? Yes. Does 4 turn into 12 by multiplying by 3? Yes. Well, then that's the rule. Multiply by 3. Y equals 3x. Just got to make sure you write it the proper way. I do not want to see any y equals x3s. We're in Algebra 1 now. I will mark that wrong. The multiplier goes before the variable. These are both basic examples. You will have to do some where it will be a bit more complex, and by that I mean two-step. You'll have to multiply and then add or subtract something. You'll get some of those in your assignment, so relax, it's not going to be the first time you see it again on the quiz. Now, these, what we just wrote, are function rules. Going back to the vocabulary, it's the third one down. An algebraic expression that defines a function. Y equals x minus 3, y equals 3x. These are function rules. Function notation says if y is a function of x, which means I figure out y by doing some manipulation to x, like subtracting 3 from it or tripling it, then function notation for y is f of x. That means that we're saying that the thing is a function of x. What you need to take away is that y and f of x are interchangeable. And by the way, that's how that f parenthesis x parenthesis thing is said. It's f of x. What you need to understand is that y and f of x are interchangeable. Sometimes you must use f of x. If the directions say function notation, you must write f of x equals, or I cannot give you full credit because you didn't follow directions. The other vocabulary here is independent variable and dependent variable. An independent variable is one we choose the values for, and the dependent variable is one whose value is determined by our choice of the independent variable. X's are independent because we choose them. Y's are dependent because we figure them out based on our X values. This is more like making an XY table as opposed to being given one. Independent and dependent can be thought of in a different way. And this will help my people who think in an English manner. Independent variable, independent is a cause, and dependent is an effect. The independent variable causes the dependent variable. Higher temperatures cause higher ice cream sales. That kind of thing. So let me show you what I'm going to ask you to do with that. I'm just going to say identify the independent and dependent variables. So tell me, what is the cause? What's the effect? What can we control? What can we not control? So first example, in winter, electricity use goes up when temperature goes down, and electricity use goes down when temperature goes up. So there's a cause and effect relationship here. The question is, what's the cause, what's the effect? Does the electricity use affect the outdoor temperature, or does the outdoor temperature affect the electricity use? And hopefully you're all yelling at, well, not yelling, but looking at your screens and saying, the outside temperature affects electricity use, because the colder it is outside, the more power you need to create heat to get it moving through your house. So this is not an example where we can control anything, because we certainly don't control the outdoor temperature. This is one that cause-effect makes more sense. The cause is the temperature, so that's independent. And the effect, the dependent value, is the electricity use. The cost of shipping a package is based on its weight. Again, cause-effect. But there is something we can control here. We can't control how much it costs to ship the package. We take our package to the post office, they'll weigh it and say, okay, now give me this much money for us to send it. What we do control is the weight of the package. We can control how many boxes of cookies we're mailing to somebody. Independent here is weight. Dependent is cost. Cost is almost always dependent upon something else. And I'm pretty sure I can safely say that in Algebra 1, cost is always dependent on something else. I just want to be cautious about saying it's always true forever and ever because, well, I could be wrong on that. Pretty sure in Algebra 1, I can say it's always dependent. Last of these basic ones, the faster that Ron walks, the quicker that he gets home. So it's not us controlling something, but it's Ron controlling something. So does Ron control the time he gets home, or does Ron control the speed that he walks at? And that might sound weird to some of you because you might say, well, both. He can change how fast he walks so that he gets home at a certain time. And I would say you are absolutely correct. And in that case, you need to think about it as a cause and effect relationship. His choice of speed affects his arrival at home time. So, if independent is cause, then that's his speed. And what has affected his arrival time. These aren't supposed to be hard. A little bit of thought, you ought to be okay. Last thing I'll ask you to do is identify the two independent and dependent variables and also write a function rule in function notation for each situation. So not only just telling me what's independent, what's dependent, but saying here's the relationship numerically. So, if a lawyer's fee is $200 an hour for his services. Now, hey, I'm seeing money, so dependent's going to be cost. What affects the cost? The number of hours we need this guy to work for us. It's $200 per hour. So from 1 minute to 60 minutes is $200. From 1 hour and 1 minute to 2 hours is $400. So the independent variable is time. You could put hours here as well, that's fine. Now the rule. F of x equals. Remember, x's are independent. So time here is our x value. So if it's $200 per hour, the functional is going to be 200x. $200 per hour, 200x. Next is a bit more of a complex example. The admission fee to a local carnival is $8, and each ride costs $1.50. Now, I see money, so cost is dependent. What is cost dependent upon? Here, it's the number of rides. The more rides you get on, the more money you got to spend. So a rule, what would this look like? So f of x equals. Well, let's deal with the independent variable first, that number of rides. And for anybody that's had me for pre-algebra and we got to chapter 11, you're about to recognize slope-intercept form. Each ride is $1.50. So you're going to pay $1.50 for each ride. And how many rides? We don't know. That's x. So $1.50x. But that's not all you're paying. To just set foot in the carnival, you got to fork over $8. So no matter what, you're paying an extra $8 compared to the number of rides. There's slope-intercept form if you had me and we got to chapter 11 in pre-algebra. That's familiar. If not, don't worry, you'll learn about it in chapter 5. But that's a complex rule. Multiply, then add or subtract.